welcome. Today is Engineering Mechanics class 66, main class number. We are in the part 2 of the Engineering Mechanics. See, part 1, class number I think 1 to 41. Class 2, class started from 41, 42 onwards. But each part, separate lecture number. Part 1 is lecture number 1 to 41. Part 2, once again lecture number 1, we have gone to 25 now. Your part 1 was, if you remember long back, part 1, force, moment, resultant, etc. Part 2 is equilibrium, types of loads and support reactions. Equilibrium already over. Right now we are in types of loads. Why I am telling? Because you can see one part 2 here, you can see one more part 2 here. Don't get confused about part 1, part 2, etc. You see correct order, you will understand. Right from beginning, go through each and every class. Then this part 1, part 2, all becomes very clear. Still, to give clarity today, part 2 I am telling, this is something else. See, we are in the engineering, this is engineering mechanics part 2. This is part 2 for types of loads. Okay, now, engineering mechanics class 61, part 2, lecture 20, I considered types of loads. I gave introduction. Point load, UDL, UVL, either represented by triangle or trapezium, etc., etc. Then, once introduction is over, then I told, now I am starting systematically the 4 types of loads. Point load, UDL, UVL represented by a triangle, and lastly UVL represented by a trapezium. These 4 are the part 1, part 2, part 3, part 4. Okay, now part 1 is concentrated load or point load. This already over earlier. This is in class number 62 already over. Then class number 62 already over. This is 63, 64 and 65. Lecture number 22, 20, 24. They are actually, see, part 1 already over. These are the preparations, thorough explanation for distributed load. Or you can tell preparations or understanding everything to go to distributed load. But this is very, very important. So once this is over now remember, as far as types of load concerned, part 1, concentrated load over. Now we are going to part 2, uniformly distributed load. Because here I consider not only load, also moment, etc. That is what you actually require later. Or now, just to understand, I'll give, see, today we are starting part 2. Someone will ask, part 2 of type of loads. No. For type of loads, part 2. Now, type of loads, part 1, concentrated load, already over in this class. But I will give just a recap so that everything is clear. See, this is a recap actually, not take much time. I will not explain much. What all I am telling now, everything is systematically told in this class. That is part 1, point load. W, magnitude. Line of action through O. Suppose you consider a point O1 randomly. Drop a perpendicular H1. Consider a point O2. Drop perpendicular to H2. Now I told magnitude is W. Line of action passes through O vertically down. Moment about O1 is W into H1 this way. Moment about O2 is W into H2 this way. Moment about O is 0. This I first told. Okay. Then I took, see, now it's important. I took a member here, some member. I considered a point ABC randomly. Then I put a load of W here. I even wrote, or sometimes people call P. Okay. Let it be, distance is x1 here. No h1, h2 now, because when member is horizontal, load is vertical, for moment you require horizontal distance. So I told x1, x2. Then I told magnitude is W, or some people call P, vertically down. Line of action passes through B. If you want moment about A, W into x1 this way. If you want moment about C, W into x2 like this. If you want moment about B, 0, W into 0. Once I finish this one, then I told a numerical example. See, I have noted down somewhere there. Otherwise, who will remember it? I noted down somewhere there. See, this way. I took a load of some random load, 20 kilonewton. I took a point A here. I took not A. I considered 3 points here. I extended this line. One more point I took. Extended this one. I took one more point. Then I called this as A, B, C. See, I told you, never by heart A, B, C, D. This distance is, I think, 3 meter. This distance is 4 meter. It's a recap. 2 point. But anyway, better because why? So that once again you understand, this is 2 meter. Then I told magnitude of the load. See, I told this way, 20 kilonewton. Direction, vertically down. Line of action passes to 3, C. Then I told first, moment about B. 20, see I told here, 20 into 3. I put some dot here to understand. 20 into 3, clockwise I told. Unit I am not writing, kilonewton meter. Then I told moment about D. 20 into 4, anti-clockwise. This is about B I told. When I want moment about D, I told 20 into 4, this way, kilonewton meter. Then I told moment about C is 0. Then I told something else, important. Moment about A. I told moment about A equal to 20 into means moment force into. I asked in the class, how much? Some student will tell, sir, 5 meter. Where is 5 there? Sir, 2 plus 3. Don't tell 5. What is there on the board, tell that one. Sir, 2 plus 3. Then I will ask, is it 2 plus 3 or 3 plus 2? Sir, both are same. Then I told both are not same. When you see, now again recap for you. When you want moment about A, put the finger here. Load 20 into perpendicular distance from A to line of action of the force. I told in my class, perpendicular distance should always start from the point about which you want to moment. So it is, I told, 2 bracket, then plus 3. I told not 3 plus 2. Okay, then I told moment about E. 20 into, from here, 2.5 because why? Plus 4. Okay, this much I told on that class. Then I don't know what I told. Maybe some explanation I given. I told also practically point load is not possible. There will be some contact length. I give some example about maps, India, world, etc. That all you go through. That was your part 1. Okay, now class number 21, class number 62, lecture 21, class 63, 64, 65, lecture 22, 23, 24. These are all preparation or getting ready for going for UDL and 2 types of UVL. That is, part 2 is uniformly distributed load. Today we are starting UDL. Next, part 3, I won't explain now. Part 3 I will write uniformly varying load represented by a triangle. Part 4 I will write uniformly varying load represented by a trapezium. Therefore, now, remember, I am removing everything now. We are in types of loads, part 2. Now we are starting UDL, where we will decide, now onwards, remember, in part 1, part 2, part 3, part 4, we not only consider magnitude, line of action and direction, we also consider moment about a required point. Okay, now we will start part 2 UDL in full detail. After this one, Later, when application comes, you should have full fluency. I will clean the full board now and start UDL now. Start now. Our serious discussion will start now. I told UDL. See, right here. Consider an UDL of intensity W, that is per unit length. Let the UDL be there from a point A to B. Between them, you should all write this yourself only. I am dictating. Let the UDL be of length L0, that is from A to B. So here L0 is loaded length considered, because right now we want to consider the entire UDL. That is very, very important. Right here, right now for our discussion, we want to consider the entire UDL. So this entire length L0 becomes loaded length. Okay, now just to consider a point to left of A, say C, at distance of x1. Don't by heart A, B, C, D. See, last time B was somewhere in between. And consider also another point to right of this B by x2. Okay, this much over. Now, see, UDL defined by intensity, that is load per unit length. It is uniform intensity. You are right. By name only you can make out. Here, W is the intensity of UDL. That is W per unit length. Don't tell kilonewton per meter, wrong. Then L0 is our loaded length at present. Class, what all we want? Right, we want, you should write it. I am telling here, you should write it. We want, considering the entire loaded length, L0, magnitude of total load, 1. Second one, direction, crystal clear, 2. 3. Line, we have to locate line of action of the total load, 3. Also we want moment of the total load for entire loaded length L0 about A, B, C and D. This is what we want. Okay, start. First write magnitude of entire load. Remember, when you want to magnitude, now I am writing, later I am removing it now. See, for the entire load, I told red color. See, magnitude means your hand should come this way. I told 1,000 times. This is the magnitude of total load for entire loaded length of L0. Now write somewhere here. Where should I write now? Okay, I can't write there. I'll remove this x1, x2 now. Okay, I'll remove it. Okay, x1, x2 I'll put later. Okay, equal to, I'll put later. You write one more sketch later. Equal to. I told for UDL, it is a distributed load. I told in general for distributed load, this all you write. If you write if you draw a loading diagram, total load is given by area of load diagram. But we are not writing load diagram. UDL, you simply like this. Therefore, W is the load per unit length. For total length L0, it is W into L0. It is the W multiplied by L0. I want a bracket. When I close the bracket, inside the bracket is the total load. Remember, right here, given by what? Intensity of load, intensity of UDL into loaded length considered. See how much I am explaining. You can see here, loaded length considered. These are very important concepts. People will tell, this all we know it, sir. What you know it, later see. This is the load. Now, magnitude over. Direction, you can write here only, vertically down, over. Now next, where is line of action? Right here. Line of action of this total load, that is already I told total load, WL0 load, will pass. Again I told you, if you represent the loading by a diagram, line of action will pass through centroid of the diagram for the loaded length considered. But here we are not drawing diagram. UDL, everybody knows it will pass center, will pass exactly midway of loaded length considered. Loaded length considered. That is at, see short form, at, from here, see, L0 by 2, from here also L0 by 2, that is at L0 by 2 from A or B. Actually remember, you have to draw one more sketch. You should not draw all this in the original sketch. See, originally I wrote a sketch, remember, see, I wrote this much. W per unit length, I told A, B, C, D. I wrote this as L0, this I wrote X1, this I wrote X2. That you write and write all the statement. Then you draw one more diagram and show this one. Do not write everything on this diagram. What happens later is confusion comes. See, this is second diagram. Write all this. So now, magnitude over, direction over, line of action over. Now we want moment. For moment, what you have to do is, this full I am removing now. I told you. Okay, now, when you want a moment, this is full I am removing. This also I am removing. Everything, including this also I am removing. Once again, original sketch. See, once again, original sketch. Okay, now, next, write one more sketch. Now enter that x1, x2. Okay, now enter that x1, x2. x1 and x2. Now one statement you write. We want now moment of, you should write magnitude of the entire load, total load about A, B, C and D. Those who want right here. When you want moment, it is magnitude of the total load. I am not writing here. You should write it. See, sometimes in the class I will tell I am dictating. Magnitude of the total load multiplied by, that multiplied I will use always like this. Moment multiplied. See, when I found total load, okay, I'll tell once again later. Multiplied by perpendicular distance from the point about which you want moment to line of action of the total load for loaded length considered. Now, what you do is take a pencil. Do not write here. First you do one thing. Light line. Mark here. Light line. Don't write. See, that's all. This is pencil. Actually, later you see when you draw SFD, BMD all, you are not doing this way. You are not writing arrow mark. So, remember, this is magnitude of the total load. Okay, right now. Therefore, right here. Moment of total load for total load for entire loaded length considered, that is L0 length. That here, to save the time, about A equal to, see here. First, what you have to do? When you want to moment, your finger should be at A. Then, what you do is, first you should write total load considered. See, total load, W into L naught. There is a bracket. W into L naught is the total load. See, this into is not moment into. This I am telling, intensity of load into loaded length. When you complete this one, see now, this term is over. This is over. Now, into perpendicular distance from moment about A, from A to line of action of this load is exactly L naught by 2 into L naught by 2. If you want, you can do one thing. Light line you write here. To understand up to some time. Light line L naught by 2. This is L naught by 2. Till you get practice. Okay. Now, those who want right here, magnitude of the total load, right here, perpendicular distance from A to line of action of the total load, it will be like this, clockwise. Okay. Now, write this way. Now, once again write. Next, okay, I am removing this one now. This I am removing now. I am going to other point. Okay. Okay, removed. Right. Next, moment of total load for entire loaded length considered L naught about B. You should not do this way. Those who want to learn everything in the beginning, work hard. B equal to, see here, B. Total load, once again, W into L naught into, from B, perpendicular distance is once again L naught by 2, but this time it is anti-clockwise. Anti-clockwise. Okay, over. Right here. Next. Everything I am removing now. Each time you write, at least once in a lifetime chance. Okay, remove everything. All gone. Once again write. Moment of the total load about C. Put the finger here. Equal to total load, once again, W into L naught into perpendicular distance from C to line of action of the load is X1 here into X1 plus another L naught by 2. L naught by 2 clockwise. Those who want right here, this is the total magnitude, perpendicular distance from C to line of action of the total load considered L naught length. Okay, now this also I will remove. See, some people start laughing. He is telling removing and not removing. Yes, I am removing. Writing once again. You should write. Gone. This I am not doing such a joke for you, remember. Moment about D I want. About D. Come here. Put finger here. Total load. W into L naught into, from here, X2 plus L naught by 2. It is anti-clockwise. This will complete our requirement here. Now I am coming to most important, that is what? Numerical value, where I will go for something else also. I will tell you what I am covering. Some extra concept I will cover in numerical. Here WL I will not cover it. That is some point in between what to do. I will tell you the numericals there. Okay. Right. Now you should write. Now let us consider a numerical example. Right? What I am telling. You consider an UDL of intensity 40 kilonewton per meter for a loaded length of 6 meter from a point A to a point B along a member. Then extend the left side further, you consider a new point called C at 1.8, anything. And right side, consider a point at distance of 2.1 meter. Now, right here, UDL defined by, once again you are right, UDL defined by intensity, load per unit length. But here, intensity is Don't tell W, no W now. 40 kilonewton per meter is the intensity. It is not the total load. If you want total load, if you want magnitude, you have to multiply that intensity with the loaded length considered. I should stop it now. Okay, then. And loaded length considered is 6 meter. Now, what we want, I will tell you. You should write everything. What we want. What we want now is, I'll write it, see, I'll dictate. To decide or to get magnitude of the total load for the entire loaded length of 6 meter. One. Second one, line of action of that load. Second one is direction. Okay. Third one, where is line of action of the total load? And fourth one, we want moment of that total load for entire loaded length of 6 meter about A, B, C and D. Okay, start. First, magnitude of the total load. See here. Once you write the sketch, now write one more sketch. Do not use the same sketch. One sketch you write, original sketch. If you keep on entering here only, you think you will save the time. Later, you will have difficulty. When you study later, it should come systematically. In the notes, I am writing same way. Okay, see now. I told we want total load. See here. This is magnitude of total load for entire loaded length of 6 meter equal to, see here, I told you magnitude equal to 40 kilonewton per meter for 6 meter equal to 40 multiplied. This is not moment multiplied. 6. Close the bracket. Answer not required. You can write 40 into 6 is 240 kilonewton. Or write your answer. This much or write the answer now. Equal to 240 kilonewton. Okay, now kilonewton, no per meter. See, kilonewton per meter into meter. I told 200 rupees per meter. You want to buy 4 meters. Total cost is 800 rupees. Okay, 200 kilonewton. Direction is down. Okay, magnitude over, direction over. Okay, now line of action. Right here. Line of action, shortcut. You should write correctly of this total load will be exactly exactly midway between loaded length. Or you can tell or you can write center of, you can write one more thing, that is center of loaded length considered. That is at, right here, that is at, this is 6 meter, 6 by 2 equal to 3 meter from A or C as shown. See here, this distance is 6 by 2 equal to 3 meter. This also 6 meter by 2 equal to 3 meter as shown in figure. Okay, write this much. Magnitude over, direction over, line of action over. Now, our most critical is moment. Okay, I'll remove everything now. I'll remove everything. Now, everything you remove. Once again, put the original sketch. Oh, I forgot distance only now. See, now I have to remember. I forgot the distances. You see, now how to do? I can't go back and see the recording there. Okay, 1 minute now. Most probably, this is 6 meter, I remember. This is 6 meter, I told. 6 meter. This I told 2.1 meter, I think, most probably. 2.1 meter. This I told, I forgot now. Okay, I don't remember. 1.8 meter. You write there. By chance, if I wrote some other value earlier here, you write, he rubbed the board then he cannot, I should have noted down somewhere there. Next time I will be careful. I do not want to give false values. So you write, or suppose in the go back to original question and change distances in case it is not same. Next time I will be careful. Okay. Now start. See now. Moment of total load for entire loaded length of 6 meter. Bracket you can write for entire 6 meter about A equal. Now do one thing. Those who want, write. When you want moment of the total load about any point for a UDL, first you write magnitude of the total load multiplied by perpendicular distance from the point about which you want moment to line of action of the load. We want moment about A, so distance should be from A. Okay, equal to. Start. Now, light line, mark here. See, light now to understand. This is your total load. See, this is your magnitude of total load. Light line. 6 meter, 6 by 2, light line. Only in the beginning. Later you should not write it. 6 by 2 over equal to start. Magnitude of total load 40 multiplied by 6. This multiplied is not moment multiplied. It is conversion. Close the bracket. This bracket will give you total load. Then into moment into load into distance from A to line of action of the load is 6 by 2, half of 6. It will be clockwise. This will be in kilonewton meter by load in kilonewton, distance in meter, kilonewton meter clockwise. Write this way. It is decided right here. This will be in kilonewton meter clockwise. Okay, over. Those who want, write magnitude of the total load given by intensity of UDL into loaded length considered. This is moment multiplied. This is perpendicular distance from A to line of action of load. Remaining point I will not tell, you should write. Okay, now about A over. Now we want about B. I'll rub this one. On. About B. You should not do this way. You should write once again. Okay, finger here. Total load, same. Into once again 6 by 2, but kilonewton meter, but this time it is anti-clockwise. Once again write over. This also over. Now, moment about C I want. This I am rubbing now. Once again I am writing. Oh, okay, over. Moment about C. See, total load, how many times I am telling, when you want moment, your hand should first move. Total load, 40 into 6 into, from C, this distance is 1.8. From here to here is 1.8. Then from here to here is another 6 by 2, half of 6. Kilonewton meter, that is clockwise over. Now, lastly, moment about D. No, I should write once again. Full I am removing. Moment about D. Total load 40 into 6 into 2.1 plus half of 6 anti-clockwise. So therefore, now you perfectly know how to find moment of an UDL about any point which lies either at the edge of the UDL or outside the UDL. Okay. That's all for this one. Now right here. Now 1 minute. I will tell you what is that now. This is the very, very important for shear force and bending moment. those who want only engineering mechanics, that is, if you want to study only engineering mechanics, maybe you are not neither civil nor mechanical, maybe electrical or electronics, you study this as a subject for passing in first year or as a subject in first year, then what I am telling now is not required for you. What I am telling now is very, very important for later shearing force and bending moment. I will explain thoroughly that one. Full thoroughly I will explain. And remember, later when you go for SFT DMD on, I will tell, go back to earlier class, study and come back. Don't be lazy and tell and expect everything from me in each and every class. Remember, I told very, very important for shear force and bending moment. This will come later in strength of materials, and also SF and BM will come almost everywhere in structural analysis. Now, make all the note. Suppose we want, someone will ask, sir, why? Why you worry later, not now. Why we want will come when you go to SF and BM. So today I am telling, you write here, why? He told it will come later. So today he told, we believed, that's all. Why he will tell later? Suppose we want magnitude of, I forgot here, magnitude of total load. I forgot. Want magnitude, I forgot to write that one. Magnitude of total load to any one side of a point, somewhere in between the UDL. Somewhere in between in the UDL portion. You can write here. Somewhere in between the UDL portion. Say a point Q. So I will call the point as Q. Y means just like that, Q. And also, we want a moment of that total load. With total load? Total load to any one side about that point Q. You want about that point Q. You do not require about other points. Okay. Now, let us consider that point Q randomly, totally 6 meter at 2.4 from here means 3.6 from here. See, from left side A, I will take a 2.4. Right side, y 2.4 is my choice. Some number I have to take. I'll take 2.4. Okay, now, write one more sketch. Now write here. Now, see this C point and D point does not, this will not come into calculation now. This will not come. So, you can remove those points. Those C and D you can remove now. It is not required. Get out. You tell get out. You are not required. Load, see. 6 meter is the, you write here, this 6 meter is loaded length considered if entire length of UDL is to be considered. If you want the entire length of UDL, loaded length is 6 meter. But now, this 6 meter is not the loaded length considered. You do one thing, should not see this 6 meter now. When you break the UDL by an intermediate point at two distances, remember the original length of the UDL gets cancelled. You should not see it here. Now, from A, 2.4, from B, 3.6. That's all. 6 meter is not there. Remember. Okay. Now, I'll remove this one. What you want is, now write here. Now, some note you have to write. Note. Maybe, for some reason, you should write all these yourself only. For some reason, you have to consider load to left of Q. See, only this much load. Only this much load. Then, you write loaded length considered will be, this is your L0. See, if you should clearly write, Suppose for, I told already, only from one side. Suppose only one side. Suppose you decided to look left side. Later, remember, you can look any one side. It's your choice. This all I will tell later, that any one side we will discuss in SFD BMD. So, suppose you want to consider, you decided to look left side. See, you write here. If you look left side, then this 2.4 meter is the loaded length considered. L0 is 2.4 meter class. Or if you look right side from this point, then loaded length considered will be 3.6 meter. 6 meter vanishes now. 6 meter is no more valid. So this is first you are right. You write a sketch this much first. To understand, correctly write the statement, you write here, this is the loaded length considered to left of Q up to A, or this is the loaded length considered to right of Q up to B. You write all these systematically and then remove this one. Okay, now I'll remove this one now. I will write here, 1 minute. I will write something there, then start the class. Now, concluding part of this class. UDL is over. Okay, see. This all I told you, put the sketch once again. A, B, 2.4, 3.6 meter. Right, that 6 meter gone. Because now you have to consider load to only one side. See, Q I told you, 2.4, 3.6. See, actually red color is not required. I halfway through wrote red, then forgot. Don't worry about color. See, now make a note here. You should write a not note, or write one note here. Note come explanation. Explanation. Note come explanation. See, here what I have to do, what you should write. See, here, put arrow mark. This face, this, see, this way. Stand here. Right here. Suppose we decided to consider the load to left of Q. That's all. Then do not see that side. To left of Q, only this much load, A to Q. So your loaded length will become 2.4 meter. Then magnitude of the total load. See, magnitude of the total load, if you want to see here, only this much length. This is the magnitude of the total load. Magnitude of the total load equal to 40 kilonewton per meter into loaded length considered of 2.4 meter. You should write intensity into loaded length considered. Now only 2.4 meter, that much kilonewton, direction down. And moment of that total load about Q. I wrote once again, moment of the total load to left of Q about Q is the total load, that is 40 into 2.4 into, see, light line, 2.4 by 2. Now you write. Later you should not write, because reason I will tell you later. Equal to 40 into 2.4 is the total load into 2.4 by 2. It will be anti-clockwise. See, it will be, here anti-clockwise. It will be anti-clockwise, there clockwise. Okay. Anti-clockwise. But remember, right now it is anti-clockwise. Later, when you go to BM and SF, I will tell you should not see direction. At that time, anti-clockwise, clockwise will not come. At that time, it is like this over. Now, same way. Right. Suppose you decided not to look left side, to look right side. Actually, you can make a note here. At that time, there is an option for us. We can consider any side, no restriction. Whether you consider this side or that side, final result will come same. But someone will tell, it won't come same here, sir. No, there is a reaction, other loads are there. When you consider everything on the member, this is a part of the loading. Other loads are there and reactions are there. When everything is considered, irrespective of see left or right side, that shear force BM, my guarantee will come same. Okay, now, right, or see, note, same note you write here, what I wrote, what I told here, same note. Suppose you consider right side, then your loaded length will become 3.6 meter. You can right line, you can write here. This is the loaded length L0 for load from A to Q. This is your loaded length L0 for load from B to Q or Q to B, anything. For A to Q or, okay, either write B to Q or Q to B, anything. This load, okay, start. First I want magnitude of total load, light line, see, only this much load, see, this is one length. I'll do one thing, see, I'll put this way, this is one length. This is other length, see, I'll put double this way, cross, 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 I'll put here. This is second one. Now, total load is acting here. How much? 40 into 3.6 down kilonewton, and moment equal to total load 40 into 3.6 into light line right here. This is 3.6 by 2. That will be like this. At that time you should not tell clockwise, anti-clockwise. You should tell like this. What is that this? I will tell you in SFDBMD. Right now you concentrate. This I will give for each and every type of loading. Okay, now with this much information, nobody will have any difficulty for UD. Point load, absolutely no difficulty. First of all, point load, what is there? Nothing. Now, point load and also UDL, these two, you would have 100% grip now. Whether you want to consider the entire loaded length or in the given loaded length, a part of it to be considered, everything considered, thoroughly practice and get firm grip. Next class will be part 3. I won't tell again and again what is part 1, part 2, part 3. Part 3, including moment and the special concept all for uniformly varying load represented by a triangle. Little big class because one triangle like this, one triangle like this, one isosceles triangle, and then one random triangle. I think most probably you require 2 parts for that one. One part not possible because 4 diagram including the special concept. Including our special concept later because trapezium will come. Okay, I will try to cover it in one class if possible. Or I will put part 2, second half, first half. I will write first half, second half. Anyway, wait for some time. Okay, thank you.